if you've studied cosmology, and in particular the Big Bang, you've probably heard the idea of there was space without space to begin with. That before the universe began, under the Big Bang theory, there was nothing. And not just an empty nothing, but nothing. And this is what I call space that isn't space, or non-space. And it's also called null space. Now, to begin with, if we look at the linguistic definition of space, it comes down to a boundless region that contains matter. It doesn't say that space is matter. It doesn't say that space is physical. It just says that space is a container for matter. And the definition for universe is essentially the same, except in the universe it just says one universe. So we have this very simple definition. Space by itself is non-physical. Space is an abstract concept. So it always exists. We can always picture a container being there that contains everything. So the container always exists. Now, in the Big Bang model, they say, oh, the container didn't exist, which is illogical, because an abstract container always exists. And there's not only that, the container didn't have dimensions, it didn't have time, didn't have any physical substance at all. And then from there, nothing initiated a Big Bang, which makes absolutely no sense and violates the law of conservation of energy, among other things. So what it comes down to is this idea of space that isn't space or non-space is purely fictional. And that's the thing that physicists just skip. And when you're analyzing any physics theory, one of the first steps you take before you even think about what are the observations and experiments is anything known to be fictional, or is anything a logical impossibility? Well, it turns out that non-space is both. It's known to be fictional, and it's logically impossible, based on standard physics. And that's because under standard physics, under Planck's physics of the zero-point field, there is always zero-point energy there. There's never no energy present. So whenever you have an abstract region of space, it's going to have energy in it. And the physical evidence says that all known space that we've ever observed has energy in it, has this zero-point field in it. So all real space has a zero-point field. And because it has zero-point field, it has quantum fluctuations that make up the quantum field, or zero-point field. And these quantum fluctuations have energy, they have wavelengths, and they have frequencies. Because they have wavelengths and frequencies, they have physical spatial dimensions, and they also have time. They have clocks, because frequencies are cycles per second, so they have to know how long a second is in order to have frequencies. So once you have a quantum field, you have dimensions and times which are determined by the quantum field. And so anytime you have space, you have dimensions and time, you've got wavelengths and frequencies. You also, coming out of the quantum field, you get the permittivity and permeability of the quantum field, which are the electric characteristics, how rapidly space can be polarized and electromagnetic field can form, and how rapidly space can be magnetized and a magnetic field can form. Well, the permittivity times the permeability equals 1 over c squared, the speed of light squared. And the speed of light is in meters per second. So once again, you see the dimensions arising out of the physical constants that arise from the quantum field. And so we get permittivity, permeability, and the speed of light being constants of the quantum field. These aren't variables. Once you have space, you have quantum field, you have constants. You have permittivity, permeability, the speed of light. And you have the physical dimensions in time and space. So there can't be any space where there's no spatial dimensions and no clocks, no time rate. They're always there. So the Big Bang Theory starts with a false assumption, a fictional assumption, and one that's a logical impossibility based on our knowledge of the physics of the quantum field and based on our knowledge of the existence of the quantum field. So we have a lie. When someone says, oh, originally there was nothing, absolutely nothing. That's a lie. It was made up. It's just make-believe. It's more religion than science because there's no evidence for it. And that's not to say that you can't make hypotheses that you test that aren't based on the science, but to make hypotheses that contradict the science is not good science. And the Big Bang is not good science. It's fictitious physics. So if you want to understand the universe, you have to start with the idea that all space is normal space. All space contains a quantum field, and all space has the basic properties of spatial dimensions, time dimensions, the quantum field, energy, wavelength, frequency, and the permittivity and permeability and speed of light, and every other physical constant that arises from that. It's all there. It's all baked into our universe. And that's what you have to start with when you do real cosmology instead of this religious cosmology, what they call the Big Bang. Well, I hope you enjoyed this video, and I hope it enlightened you on the problems of having space that isn't space, what I call non-space. And we have to just set that aside and start over using real physics for a change. And if you like my video, please like, share, or subscribe. And if you're interested in reading about non-space, it's one of the 100 greatest lies in physics from my book. And I also talk about a little bit about the way we have to think about the zero-point field in my book, Zero-Point Universe. I don't really get into cosmology because when it comes right down to it, until we know how electrons and protons are produced, you're just guessing at cosmology. Once we know how electrons and protons are produced without any matter, then we will have a starting point to really understand the cosmology of the universe. And I'm waiting for that to happen. So, thanks for watching.